Hey there, and welcome to my tutorial about how to draw water drops, the first video of my new series about water. The plan for this episode is to teach you all the basics of how water drops work, so that you can draw them in any scenario. We'll take a look at water drops sitting on different surfaces, hanging down, falling, and splashing into water. I'll be very thorough about how light and shadows behave, and why drops are shaped the way they are. So, let us start. Thank you. At first we have a drop sitting on a very simple monochrome surface. I will show you very quickly the basics of how to draw it. And when we're done, I will switch over to a prepared drawing and explain why the drop looks the way it does. So I have my palette here, and at first I'm going to sketch out the general shape of the drop. It is very round, quite circular, but it has these corners here that are connected with the ground below. And the lower part is kept quite flat. And now we switch over to a darker color and sketch in the shady area. Now the light is actually coming from this direction, from the front and slightly from the side. And the shady area is facing that light source. Now that seems kind of counterintuitive, but later I will explain to you why that is the case. Smudging the colors together to have a nice gradient. Also, by the way, I'm rushing quite a lot here, so it's not gonna look great, but that's why we have the prepared drawing. And then the lighter area. Again, we want to establish a gradient, so I will pick brighter and brighter colors. And the back is especially bright. And some of that bright light is also pulled over here along the bottom. You can imagine some light is reflected off the ground, and therefore the bottom is a little bit brighter. Smudging everything together once again, and then we take care of the highlights. For that we are picking the brightest color, and I'm sketching quite a lot of white here at the back, and also the direct highlight that is straight coming from the light source. Again, you can smudge out a little bit here and there, and it can also be that there are some light reflections on the other edges, with a few tiny highlights here and there. And then the drop shadow. The light source is quite low, therefore this drop is casting quite a long shadow. And it is quite dark and sharp, which you would normally think, since water is transparent, that the drop shadow would be much weaker. But that is not the case. And then I'm also pulling in some of the shadow over here, right below the drop, to emphasize its round shape. And speaking of round shape, the drop shadow obviously has to look very round because of the shape of the drop itself. And now something quite peculiar. There is a light reflection within the drop shadow. Here we have a focus point whose position depends on the angle of the light. And then you pull over some of this bright light closer to the drop. And the closer we get, the more the light is starting to fade out. And we want to establish kind of a gradient, a triangular gradient. So the center here is still quite dark. And we pick darker and darker colors and fill everything in, like so. And here at the top we also have a little bit of a fade out. And then I can come in with the brightest color and brighten up the focus point and some of the edges here and there. Now this looks very sloppy, but it gets the point across, and as I mentioned, I have a prepared version. Now I didn't only prepare this drawing here, but a bunch of extra illustrations to give you a better understanding as to how water drops work. For example, why do they have that round shape? That has to do with the fact that water molecules attract each other. This is called cohesion. Don't worry, I won't dive too deeply into the physics aspect. It is not really necessary to know when you just want to draw water drops, but I still find it interesting. And understanding how nature works can be helpful for illustrating it. So what does cohesion have to do with the round shape of water drops? Well, because of it, there is something called surface tension. Water molecules inside the drop are pulled equally in all directions. If you add all of these forces up, you will have zero, a state of balance. those at the water's surface experience a net force inverse that is not zero. However, they prefer to be in a state of balance, a state of minimal energy, as to say. A sphere has the smallest surface area, therefore that shape has the least amount of molecules on the surface. That is why water drops always want to form a sphere. But there are other forces in the way, like gravity, air resistance, and others. So that's why our drop here looks more like a semi-sphere. Gravity is pulling it down on the surface. There's another factor, but I'll explain that a little bit later in this video. Next up, I want to better illustrate how light and shadows change depending on the light angle. For that purpose, I made a photo series and put it together in a short animation. The setup is very simple. I darkened the room and just pointed my desk light at these water drops. And for every photo, I changed the light angle. You can see that there is a very strong contrast. That's because of this particular lighting situation. Outside in sunlight, it would have a much weaker contrast, of course. You can see how the darker area in the water drop always faces towards the light. The yellow, by the way, is just simply a wall at the back. I gotta say, it's kind of mesmerizing to look at this. Well, let's move on before we get completely hypnotized. The main highlight is not exactly directed towards the light source, but lower than that. That's because the light rays that we see need to be reflected towards our eyes, logically. The shape of the highlight, by the way, depends on the shape of the light source. It looks different if it's a desk light, a window, the sun in the sky, or something else. So you might also wonder why the lighter area is at the back of the drop and why there are these reflections in the drop shadows at low light angles. I found an incredibly useful website with tools to illustrate those phenomenons. So this might look confusing at first, but it's actually very simple. With the glass tool, I built a hemisphere and set it up so that it behaves more like water. The ground is just a mirror line, and the light source is just a dot that sends out light rays in all directions. This side simulates how light rays change direction when they hit different surfaces. When they make contact with water, for example, part of the light ray is getting reflected, but a significant portion travels through it. When that happens, it changes direction. This is called refraction, and occurs when light switches from one medium to another. In this case, it is from air to water, and vice versa. You encounter this effect in your normal life. For example, when you have a straw in a glass of water and you notice a weird bend when looking into the water from above. So you might have already noticed that at the back of the water drop there's a much higher concentration of light rays than coming from the front. And now let me change the position of the light source. For very low light angles, you can see that a lot of light is focused on the ground behind the drop. This explains those light reflections in the middle of the drop shadow. And the slightly curved shape of the light reflection is simply because of the round shape of the water drop. Alright, that was a lot of information I threw at you right from the beginning. I hope you are still with me. Now you already have a good set of basic knowledge. So let's move on to the next illustration. Again, we have some drops sitting on a simple surface, a metallic surface this time. You probably noticed it already, the drops are kind of weirdly shaped. I just explained to you that water always wants to retain a spherical shape, so what the heck is this? Well, now that other factor that I hinted at before comes into play, adhesion. Very similar to cohesion, but it's the attraction between different types of molecules. The surface below the water drops obviously is also made of atoms and molecules. Depending on the surface material, the shape of the water drop can change drastically. To better illustrate this, I made a simple drawing. So there are materials that are hydrophobic, which means that they repulse water. The drop is more spherical shaped in that case. The inner angle between the water drop surface and the surface below is very wide. A few examples for those kind of materials would be various polymers, shark skin, or lotus leaves. You might have heard of the lotus effect, when water just pearls off the leaf. In the case of a hydrophilic material, the drop is getting stretched out. The surface molecules are exerting a force that pulls the water molecules towards them. In this case, the angle from before is much sharper. Some examples would be glass, many coatings and paints, and also steel. And so that is why I chose a steel surface for this drawing. Not only do the drops get more stretched out, but they can look more irregular. They also might have some small corners here and there. This also depends on the texture of the surface. The light reflection is a bit different. To explain this, I made another photo series. So these are just some drops on a large knife. The light comes from the back and slightly from the side, and then it is moved further up and towards the front. You can see that the light reflections form some kind of string from one side to another. It follows the curvature of the drop, and its ends are normally connected to some sharper corners. In most cases, this string is uninterrupted. And if you look closely, you can see the texture of the steel in these light reflections. Drawing these drops therefore is a bit more complicated, but they still follow a lot of the basic rules like the first drop. For example, the position of the highlights, or that the darker area is facing the light source. You just have to separate those darker and lighter areas into smaller parts if your drop has a more complex shape, and the back of the drop can transition to a darker shade from the lighter area. Next up we have another drawing of a drop sitting on a surface, this time a lotus leaf. So you already know that lotus leaves are very hydrophobic, and therefore we have this round shape for the drop. The main reason why I made this, however, was to illustrate another effect. If you look closely at the leaf texture through the drop, then you can see that it is warped. Once again, that has to do with refraction, the same principle like with the straw in your glass of water. In order to better show how it is warped, I made yet another photo series. So here we have water drops of different sizes sitting on my cutting mat, which has this neat grid on it that will nicely show the warping. I am starting with the highest angle that I shot. The distortion isn't all that strong yet. However, as I lower the angle, the warping becomes more and more obvious. It kind of looks like the mat is somehow expanding, but believe me, it's just water. A thing to pay attention to is that the lines of the grid start from the original positions and then progressively curve up. Alright, next up I show you a falling water drop. I know, in the logical progression we would at first take a look at hanging water drops, but falling ones are actually simpler, and some of the basics also apply to hanging water drops. I went a little bit overboard with this drawing, I do admit, but it still nicely gets the point across. This water drop here is perfectly spherical. It's more common that they still have a bit of wobbliness to them, but we'll keep it simple. You probably noticed right away that the drop shows an image of the background, but flipped around. How so? Let me show you a little experiment to give you another example of this. What you can see here is this drawing of an arrow and an empty cylindrical glass. But the glass walls themselves are causing some light refraction, but when we fill the glass with water, you can see how it starts changing. The arrow all of a sudden is inverted and also gets distorted. The glass of water acts as a lens. Not a very good one, so that's why we have a lot of blurriness and distortion, but still one nonetheless. To illustrate how a circle acts as a lens, I put another scenario together here in the simulation. It's even simpler than the previous one. We just have a circular shape that's supposed to be a water drop and a point light source. I drew a line straight through the center of the sphere so that I can show you that the focus point is actually flipped around. So let's make the connection with the water glass experiment from before. If you imagine that the tip of the arrow is right where our point light source is, and the circle is our water glass from above, then you can nicely see how the tip of the arrow appears to be facing the opposite way. This simulation only shows this effect in one dimension, left becomes right and right becomes left, which is exactly what happened with our cylinder shape. But this water drop is not just flipping left and right, but also up and down. And that's because it is not just circular in one dimension, but in all three. It's a sphere. I mentioned that it's not a perfect lens, so you can see some distortion. The closer to the edge, the more squished together the image looks like. It also gets more and more out of focus. You don't really need to add shades to the drop, but highlights. The light comes from the top left, and so that's why the largest highlight is located up here. But I also went ahead and added some light reflections on the other sides. In this environment, the light is not just coming directly from the sun, but also indirectly, reflected by the environment itself. Next up I have this water drop hanging off the tip of a leaf. And as you can see, the background is flipped around again. This is obviously not the perfect sphere, but it's close nonetheless. That's why you see a similar effect. But you have to make some adjustments to the warping of the picture, stretch it out a bit more vertically, especially upwards. The tip of the leaf, by the way, is inside the water drop. In cases like these, it's possible to see some warped, blurry reflections of the leaf itself at the top. These follow the curvature of the drop too, and so you can see those arcs. Okay, next up let us talk more about the shape of these hanging water drops. There are several stages a drop goes through when hanging off and detaching itself from some kind of ceiling surface. At first the water is accumulating, and once it gets large and heavy enough, the detachment process begins. I explained to you the cohesion effect before, water molecules wanting to stay close together. In this case, the main opposing force is gravity. There is a point when the surface tension is losing against the gravitational pull. The drop is getting lower and lower, and the neck is starting to form. The neck is progressively thinning out, and these angles are getting sharper and sharper. You can especially see it at the top here, where the water starts to form a cone. By the way, this point here is the closest a water drop ever gets to the typical water drop shape you normally see. Water drops actually hate having this shape. It's not very efficient in terms of surface area, and so it wants to pull the tip back towards the center as quickly as possible. Therefore, water drops in mid-air or rolling off a surface do not have that shape. It still might be good for simple illustration purposes, like when you have to convey that some kind of liquid is inside a container. But it is not realistic, except for this incredibly brief moment here lasting shorter than a millisecond. The neck also detaches from the top. It wants to retain its spherical shape, and therefore it swiftly contracts. It's common that the neck also forms some kind of ripple pattern before focusing into one or several tiny drops. The ceiling of the big falling drop is snapping back once it's freed from the neck. And as it falls, it will wobble around a bit. You will see these wobbly shapes way more commonly than close to perfect spheres. Alright, now we're getting into more complicated territory. I am talking about water drops splashing into water. But don't worry, it's not that bad. The shapes are going to be more complex, but you still have a lot of creative freedom. So when a drop of water falls into a pool of water, that drop is not just immediately joining with the larger body of water, but it still has momentum. It displaces the water around it on impact, and so one of the first stages would be a crown forming. This is how you sketch it out. For the very basic shape, just draw a short cylinder. Then we follow the top circle and draw these round shapes. Some of them are lower and some of them are higher than the top circle. And they have the same distance from each other. Of course, those at the side look more closely packed because of perspective. And what you can also do is tilt them slightly when drawing them more closer at the sides. And now the second stage of the sketch. First, I am rounding the walls a little bit, because normally they are not just straight up. And then we curve around these drop shapes and form these kind of necks and bridges between those crown spikes. The lower we are, the flatter this wave shape looks like, and as we get higher, this kind of slender neck is starting to form. And here we have some overlapping, and don't worry if it looks wobbly, it really doesn't matter all that much, just have fun with it. Here at the bottom some slight indications for the ripples. The inside of the splash is quite dark, and then here and there we have some drops that might have detached itself from the spikes, and also some tiny droplets from the splash. And there we go, this is a simple way to sketch out a splash crown. I don't have all that much time to make a full painting live, so let me point out the important parts with the prepared painting. First of all, some kind of light ring is formed right below the crown spikes. It has a wavy shape always curving up to the spikes. To properly illustrate those gaps, we make a curved shady area and add some highlights at the edge and in between. For the drops themselves, add some round shadows and highlights to emphasize their shape. As for the walls, add a slightly wavy pattern, alternating between darker and lighter lines. Not that much time has passed yet, so there aren't many ripples around the splash, maybe one or two faint ripples. You can paint those by once again alternating between light and darker lines. Make those lines very soft though. Also the ripples get their own shiny highlights. And then of course the reflection of the splash on the water surface. Here you have to consider the perspective. It's not just the same picture flipped around. We look at the original splash from above, so the reflection has to look as if our view angle is from below. You don't necessarily have to give the reflection as much detail as the original, and it will look a bit wobblier because of the ripples. Those are a couple of basics that I can explain to you, but of course they can look very different depending on the lighting and other factors. At this point, I want to recommend that even after you watched my tutorial, it is still a good idea to look at references too. I give you that advice in general, not just for this particular tutorial. If you know the basics that I'm trying to teach you, you'll have an easier time analyzing and deconstructing the references you look at and apply what you are seeing to your own artwork. Okay then, now let us think about what happens with this splash as time moves on a bit further. This crown will collapse and fall back into the pool, creating a couple of smaller, more chaotic ripples. The water surface in the middle, which has been pulled down by the impact of the water drop, is bouncing back up. And so you will get a tower shape like this. You have a long neck connecting with the top of the tower, which is more spherical. It can also happen that a drop detaches from the tower and goes flying for a short while on its own. And this bouncing back and forth motion will happen several times, getting progressively weaker until the surface calms down. You can also see way more ripples now, since more time has passed. Often these ripples show some kind of interference pattern. You can see that at certain angles, the water surface looks flatter. A tiny detail, but it can give your painting a nice little extra touch. In this painting the light comes from the back, so the side of the ripples that face the light appear brighter, especially right at the center. You mostly paint with gradients here. You can see that the contrast is weakening as the angle changes away from the light angle. The reflection of the tower is definitely easier to draw this time compared to the crown shape, but now you have more ripples distorting the reflection. What you simply do is chopping up the reflection, so you mostly just focus on the brighter areas of the ripples and paint the individual segments of the tower slightly displaced from each other. There is not really a need to be super accurate about it. I certainly wasn't, but I still think this looks convincing enough. Alright, so I have one last drawing to show to you. As always, I made a big special drawing that incorporates what I learned for this tutorial. And here it is, a lovely macro scenery with lots of flowers, small animals, and a tiny lady. It just recently stopped raining, you can see small droplets sitting on the leaves, and that's also the time when the snails come out again. There are still some large drops falling from the leaf tips and roofs, and I imagine it would be quite uncomfortable if one of these lands on your head when you're that small. That's why this nice lady carries this leaf umbrella to protect herself and her snail friend. You can see that a big drop has splashed off her umbrella. By the way, this young woman is supposed to be Adrietty, a lovely singer on YouTube and Twitch. She loves snails, and so I thought this idea would be perfect for a macro scene like this. If you want to know more about how I made this painting and about Adrietty, then you can also watch the narrated timelapse video, which will come out 1 week after the release of this video, so stay tuned. I'm gonna be honest, this topic has been way more fascinating than I initially anticipated. I didn't expect that there would be that much physics involved, so my years of studying physics turned out to be extra useful. However, at this point I want to say again that you don't need to know all of what I just explained. People have different ways to draw and different interests, so take whatever you deem helpful with you. Again, this does not only apply to this tutorial, but to all of those I made. If there was even just one useful piece of knowledge for you in this video that you didn't know before, then I'm already glad. As I mentioned at the beginning, this video is part of a tutorial series about how to draw water. There will be many others, about bubbles, waves, waterfalls, rivers, lakes, and so on. I'm looking forward to those too. I've been wanting to get better at drawing water for quite a while, and now is finally the time. So, thank you so much for watching. I hope this tutorial was helpful to you. As always, if you have any questions or constructive feedback, then please leave a comment down below. And for more information and links, please check out the description of this video. There's quite a lot in there. Alright then, have fun drawing.